Hey everybody, we're going to start our new unit today through these video modules. It should be pretty quick and simple. I hope it goes well, and I'm confident that you guys are going to be able to figure it out. We are starting the rectangular approximation models for the integral. Okay, this entire unit is on integration or studying the integral. It's very, very cool. Tells us some very important information. Just like the derivative told us important information, the integral will too. We're going to jump right into this question. Okay, the integral is going to eventually tell us area under the curve or area under a graph. So we're going to look at ways that we could estimate area under a graph for a specific situation. Okay, kind of erase what I've already done here. I want you guys to go ahead and plot these points as I've done. We're tracking the velocity, or rather the speed of a bike on 2-second intervals. So go ahead and plot those points from this data up here, and we'll talk about them, do some work, go from there. Okay. Notice that it only records the speed every 2 seconds. So technically, there is no recorded or no certain values in between. I could do my best to draw that curve. I could do my best to guess, but all I know are these 2 points on either side. Okay. Well, these points. So what is the least distance he could have traveled over the first 2-second interval? So what we're going to do is we're going to chunk this up into this 2 interval, this 2-second interval, this 2-second interval, this 2-second interval. What is the least distance he could travel? Well, we're going to assume that he traveled the slowest distance for the entire time, the entire 2 seconds. So if he started at 10 feet per second for that entire 2-second interval, let's assume that he traveled at that 10 feet per second and then jumped up to 14. Okay, well, I like to draw in a little rectangle. That's what we're finding. We're finding the area under this curve, which my base would be time. That would be 2 seconds. My height, well, that would be my speed. That would be 10 feet per second. So I'm finding the area of a rectangle over here. Area equals base times height. My base of 2 seconds, my height of 10 feet per second. The area underneath actually gives me the distance traveled. So here I'm assuming it's 10 the whole time over 2 seconds. That's why I get 20. Okay, that's the least amount he could have traveled. Similarly, maybe I change this a little bit and I say, what if we assume he was going the fastest over that entire time period? That he was only going 10 seconds right at 0 and then jumped right to 14 for the rest. Well, I can find the area of that rectangle, which again gives me the distance. 14 feet per second times 2 seconds. My seconds cancel out, and I get 28 feet. Okay. But maybe these aren't the best ways to estimate. So another way that I could estimate is by saying, what would the middle velocity be? If I had to guess, what would the middle velocity or an estimate for the speed at 1 second, right in the middle? Well, if one side's 10, one side's 14, let's say 12 feet per second. And I'll assume that it was 12 for the entire time, again making a rectangle and finding the area. There, 12 times 2 would be 24 feet. Okay, so I've gone ahead and I filled in my graph, my chart down here, 20, 28, 24. And eventually we're going to find what was the low estimate for how far he went, what's the high estimate for how far he went, and what is the midpoint estimate for how far he went. All based on the lowest velocity, the highest velocity, or the middle velocity. Okay, so I'm going to end the video here. The next video will start with this information all filled in, so you need to fill that information in before moving on to lesson 1, video 2.